So come to the third part of this exercise 5.8 and yes, so we come to the third part of this exercise 5.8 and this is like an extension of the earlier question. We had done the same question for Rolle's theorem and we had analyzed that in all the three cases we are not able to apply the Rolle's theorem. Now they ask us to check whether mean value theorem can be applied or not in this case. Many cases where Rolle's theorem doesn't apply, mean value theorem does get applied. So we have to check whether it will get applied or not, and that is what we are going to do. So problem number 1 says that f of x is greatest integer x between 5 and 9. We all know that for mean value theorem to apply we require two conditions. First condition is continuity, second condition differentiability. Now we know that these are not continuous. We all know that the greatest integer function, what kind of graph it is? It is that kind of a broken graph. It's not continuous. So because it's not continuous, we are not going to be getting the we will not be able to see continuity. You can show in two ways. One is all that algebraic x tends to a and all that, or you can show this graph and you can say that this is why it is not continuous and that is why we will not be able to show the mean value theorem. So I will prefer to draw the graph. So you can say that here, see, so this is the graph of f of x and it is clear that it is not continuous. It's not continuous. Therefore, mean value theorem cannot be applied. Right, otherwise we can do algebraically also, like limit as x tends to a minus, limit of x tends to a plus, limit as x tends to a and all that. They are not tallying and that is why they are not continuous. That way also you can say that is not continuous, but otherwise this way also. So same logic we can apply here. It's the same thing, only interval is changing, so we'll do the same thing. Yeah, there should be some change. We've been doing algebraic for quite some time. It's very boring. So let's have this little pictorial things. Yeah. See, mine is approximately 1 centimeter would be approximately correct, but when you do it, it will not be correct, so please measure and do it. Okay, never draw diagrams by just guesswork. If it doesn't show a proper scale, then your purpose doesn't serve. So please do it by measurements. So that's about it, and then we will check how we can draw this. Between -2 and -1, the function goes to -2. The function goes to -2. Then between -1 and 0, function will go to -1. Then between 0 and 1, function will go to 0. Between 1 and 2, function will go to 1. That's it. So this is how the function is, and these are the graphs. Right. So we observe that the graph of f of x is not continuous, therefore mean value theorem cannot be applied. Right? When it is not continuous, it will definitely not be differentiable. So there is no point of exploring into the second property. So these both are like this. But next case is not like that. It is polynomial function, so continuous and differentiable. So we can check what happens. Here, f of x equal to x squared minus 1 is a polynomial function. Therefore, continuous on 1, 2. Okay. Also, the f dash x is 2x, which is a polynomial function. Therefore, f of x is differentiable on 1, 2. Right, it's defined everywhere. On 1, 2, you take any point, you are able to get an answer. So, it is differentiable on 1, 2. So, because these two are there, we have to check for the mean value theorem. Now, we will see what is f of 1. F of 1 is 1 squared minus 1, which is 0. And f of 2 is 2 squared minus 1, that is 4 minus 1, 3. Therefore, consider f dash c to be equal to f of b minus f of a by b minus a. So that means 2c equal to 3 minus 0 by 2 minus 1. So that is 3 by 1. That is 2c. Or rather, c will become 3 by 2. Isn't it? So that way your value, once again, I don't know why I see some other extensions. Alright, so that's it. So C is 3 by 2, that means it's 1.5. Definitely lying between 1 and 2, isn't it? It is lying between 1 and 2. Therefore, we can see that C is 3 by 2, which is 1.5. Therefore, C equal to 3 by 2, which is 1.5, belongs to what? Belongs to 1, 2. Therefore, mean value theorem is verified. Now, suddenly, that's what I just saw now. In the previous question, that is question number 5, they have given a question like this: find all the C where f dash C is equal to 0. So, so that part we have not done actually. We have applied the mean value theorem, but we have not checked that part. Find all the C where f dash C is 0. So that we need to do it. So question number 5, part 2. Okay. Find C when f dash C is 0. So f dash C, I don't know what was there. What was f dash C? 3c squared minus 10c minus 3. 3c squared. Therefore, minus 10c minus 3 equal to 0. In the earlier case, I think we got 10 or something, and that 10 came here. That was minus 10. So when it came here, it became plus 10. Then it became 7, and we split it up and we did. Now this is a case where they are asking us to check f dash c equal to 0. So let's work it out. 3 into 3, 9. So you could write it as 3c squared minus 9c minus c. No. Because 9 into 9 minus 1 will give you plus 9, and we want minus 9. No, so this will not work. Okay, though apparently it's okay, but the sum and product, that thing doesn't come. So we will take the quadratic formula and do it and see what comes. So it's like c is minus b, that is 10, plus or minus root of b squared, that is 100, minus 4ac, 4 into 3 into minus 3 by 2a, that means 6, 2 into 3, 6. So 10 plus or minus root of 100 plus 4 3s are 12, 2 3s are 36. I hope it's correct. 9 4 36, yeah. 136. 10 plus or minus root of 136 by 6. Now how to find this? I have our good old thing, isn't it? Let's see. Like this we'll group. 1 ones are 1. 1 plus 1, 2. 1 minus 1 gone. 36 brought down. 21 ones are 21. 22 twos are 44. Cannot 21. Let's attach this one. What do we get? 21. What's left? Yeah, 515. Okay, we want to get place a decimal 2 zeros. So 225. 5 5s are 25 to carry, 5 2s are 10, 12, 1 carry, 5 2s are 10 and 1 11. Yeah, you could have 2 to 6 also. Let's check. 6 6 are 36. 6 2s are 12 and 3 16, 12 and 1 30. How about 7? I don't think, but let's check. 7 7s are 49, 7 2s are 14, 18, 1, 7 2s are 14 and 1 15. Yeah, it is 6 you can attach. So it's like 1366. We will not proceed because we have bothered only about one decimal place. 10 plus or minus 11.6 by 6. So what will come? 10 plus 11.6 by 6. 10 minus 11.6 by 6. Yeah. So how much are these coming? Whether these are lying? Find the C's they are saying. What are the C's? It is 21.6, isn't it? Yeah, 21.6 by 6, and this is minus 1.6 by 6. 21.6, 6 sevens are, 6 fours are, so 6 threes are 18, and 3 left, 3.6, and here it is minus 0.6, 2s are 12, 12 and 4, so 6 6 are 36 and so on. 36, then 4, 6, 6, so on. So those are the points, but I always need to check. Yeah, correct. So those are the points where this happens. They're just asking us to check all the see where this is happening, in a kind of in an attempt to get the roles. So that is how it is. So it's like patching up between roles and Lagrange, and this I somehow overlooked. So this is it. So that's all. We finish the exercise with this. With a new exercise, we will do the next video. Thank you.